In this video, I will explain how to classify turning points using the tabular method. So the tabular method is simply looking at the derivative on either side of the stationary point and deciding based on that whether it's a maximum or a minimum point. I call it the mathematical microscope. So for example, in the graph shown here, we can see that we've got a stationary point here, and on the left of it, we've got a positive gradient, and on the right of it, we've got a negative gradient. So this creates like the shape that matches a maximum point. Similarly, over here, which is a minimum point, if I go to the right, I see a positive gradient. If I go to the left, I see a negative gradient. At the stationary point, it's 0. So this corresponds to the shape that will give me a minimum point. So the idea is quite simple. We look at the y dx before and after the stationary point. If it goes positive and then negative, then we can see that it's going uphill. At the stationary point, it's going horizontal, and after it's going downhill. So this corresponds to a maximum point. On the other hand, it could be going negative, then positive, so it's going downhill, then horizontal, and then uphill, and this corresponds to a minimum point. A big plus for the tabular method is that it will always give you an answer. It will be able to classify any stationary point as being a maximum or a minimum. In this example, we are asked to find and classify the turning points for y is x cubed minus 3x squared minus 9x plus 8. So I start by finding dy dx, which is simply 3x squared minus 6x minus 9. I set it equal to 0. I divide throughout by 3 to get x squared minus 2x minus 3 is 0, which factorizes into x minus 3, x plus 1. So we've got x is 3 or x is negative 1, and therefore I can substitute back to find y. When x is 3, y turns out to be minus 19, and when x is negative 1, y is 13. So to determine the nature of the stationary points, I will draw up tables and investigate the sign of dy dx on either side of each of these stationary points. So for x is 3, the table looks something like this. I've got the value of 3, and I go a bit to the left and a bit to the right, so 2.9 and 3.1 seem like sensible choices. When x is 3, dy dx is 0. When x is 2.9 is minus 1.17, and when x is 3.1 is 1.23. So we're going downhill, then 0, then uphill. So this corresponds to a minimum point, and therefore I conclude that the point 3 minus 19 is a minimum point. Similarly, for the stationary point at x is negative 1, I draw a table. I will be looking at negative 1, of course, and then a bit to the left and a bit to the right. So when x is negative 1.1, the dy dx is 1.23. When it's minus 1, it's 0, and then it's minus 1.17. So this time it's going uphill, then 0, then downhill. So this corresponds to a maximum point, and therefore we conclude that the point negative 1,13 is a maximum point. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.